I suppose a greater, more present worry would be if the techniques of creating or of varying microorganisms were to fall into the wrong hands. I mean, biological warfare has been experimented on by some of the great powers, and if the techniques fell into the hands of terrorists, especially if the terrorists, for religious reasons, want to die, and therefore don't care whether they destroy the world.
Right.
I think that's probably more of a worry than the kind of thing you were raising of creating life.
But the bottom line then, summary, if I'm hearing you correctly, is you would agree, presumably, with the statement that whatever, 100 years or 500 years from now, people will look back at this era and sort of smile at the mystery that we once thought was embedded in life, and it will just be another concoction of chemicals that happens to be able to carry out certain processes, and people will shrug as opposed to revere this entity that forms, at least on this planet.
I suppose if there's a lesson from history, that one can look back on earlier eras and feel that way, yes.
Well, I mean, at the end of the 19th century, there's a famous statement in physics that I'm sure you're familiar with. Lord Kelvin is usually credited with saying it. It's unclear that he actually did. That, all the laws of physics were worked out except, this or that constant of nature that needed to be evaluated to the 6th or 7th decimal place. And of course, that was before the discovery of special relativity, general relativity, quantum mechanics. So it's spectacularly wrong. So it's spectacularly short-sighted.
Yes.
But do you think it's possible that there is a discovery, a phase, a step on par, say, with quantum mechanics, which, for physicists is the revered step in our understanding of the natural world, that we're completely missing right now?
Yes, a different kind of precautionary principle. You've got to be precautionary about what you say and not fall into the Lord Kelvin error.
Right.
I think it was Lord Kelvin also said radio will turn out to be a hoax. And what else did he say?
I don't know if I know that one.
He said heavier than air flight is impossible.
Geez, you're really taking my hero and just cutting the legs out of it.
Well, no, he was a great physicist for his time, but he also gave Darwin some grief because
I opened a can of worms here. This is fantastic. Yeah, go ahead.
He gave Darwin some grief because he calculated that the sun was too young to have allowed time for evolution, and that's because he thought the sun was a fire, burning fuel, and had no way of knowing that the sun is a nuclear reactor, and so Darwin was intimidated because physics was the senior science, and so in a way Kelvin kind of came a bit heavy on Darwin and said, well, physics proves that evolution is not possible. What Darwin should have said, well, the evidence for evolution is overwhelming, so your physics must be wrong.
Touche. So if we go from life to intelligence, conscious self-awareness, there's a similar collection of puzzles, obviously different in detail, but revered by many through the centuries. And in the modern era, David Chalmers is famous, down at NYU now, famous for articulating the so-called hard problem of consciousness, right? The problem that if matter is all there is, matter and fields, and if electrons and quarks and the entities that they build up, protons and neutrons, if they have no inner world, if the lights aren't on inside an electron, if it has no inner sensation, if a third-person account precisely describes what's going on with an electron, there's nothing else. How could it possibly be that when these particles swirl together, they somehow generate an inner sensation, a quality that simply is absent at the level of the fundamental ingredients? So, he was dividing up the problems in neuroscience and brain science into those that have to do with the mechanism, the function of the brain, which ultimately can be difficult to work out, but it's clear what to do to figure out, what's going on when, my arm goes up and down, what sort of brain signals are making that happen. But he considered a qualitatively different question to be the one that I was referring to, namely, how can the lights turn on? Do you see that distinction?
Well, I always confess myself baffled by it. I do see it as a profoundly difficult problem. I am committed to the view that there is nothing there other than physics. There's nothing there other than, as you say, atoms and electrons.
And I agree with you. But where does that sensibility come from? Is it based on evidence?
I suppose it comes from the feeling that, as an evolutionist, we start with physics, and then we get chemistry, and we get a process, Darwinian natural selection, which gradually builds up nervous systems step by step. They get more and more complicated. I can't see any other way but that.
Could that be limited mental acuity and creative powers?
I think it has to be that, but I'm more curious to know what you think. But as a physicist,
I thought I was asking the question. No, it's good. No, we actually we're going to go back and forth on questions, and I agree. I can't imagine that there's something beyond Schrodinger's equation of quantum mechanics and the interactions of the particles that's going on inside this physical structure inside of my head. But I still feel deeply puzzled by how it is that I can sit here and have this inner world. Everything that we do in physics, and think science more generally, is so focused on the third-person account. We can look out, objectively see data in the world, find the patterns in that data, articulate the patterns in mathematical equations, use the mathematical equations to predict what's going to happen next, or the probability of what's going to happen next in a quantum mechanical framing, and that's what we do. We never have this turn inward to try to have that same kind of rigor and description of what's happening inside of our heads. Now, what David Chalmers says is, he says that's not just a small issue, that's a huge issue, if I understand what he's saying correctly. He's saying we perhaps are missing a side of the story which would endow perhaps electrons and quarks and other particles with a degree of proto-consciousness. Maybe there's something beyond mass and charge and spin. Maybe there's something there, and only by taking into account that quality that we've been missing can a lot of those particles yield the sensations that we're all having right now.
Starts to sound dangerously like Deepak Chopra if you're not careful.
Well, I'll tell David that you said that.
I'm also intrigued by philosophers' thought experiments where they say things like, imagine that you could make an exact copy of every single atom of you, and there are two of you standing side by side. Which one is you?
Both. I have no doubt that they're both.
Yes, but then presumably you would have the same consciousness.
Yeah, same memories.
But then they would
diverge.
Start to drift. They would start to drift apart.
Yeah, so there'd be two of me.
Yes.
I'm not sure that would be such a good thing for the world. But that's on that question. I feel secure in saying that. Obviously, if one day we can do this, it'll be the best way to find out. But part of that sensibility for me, and I'm wondering if it's the same for you, I don't think that consciousness has to take place inside a particular physical structure, the human brain or the brain of any other animal. I think that once you replicate the function, you've replicated the experience. Do you?
Yeah, and I think if you could somehow upload everything into a computer, that also would have to have our consciousness. But these I agree with David Chalmers. It is the hard problem, and it's certainly too hard for me. But I wouldn't take the leap to say that therefore, I know something like every atom must have a little smidgen of consciousness or something like that.
No, I don't think he took that step without a great deal of difficulty. was
Yeah.
basically banging into every possible avenue that he pursued for many years, and it almost felt like there was no other place to turn. And having not gone through the journey that he and others who spend their lives trying to figure out consciousness have gone through, it's hard to know whether I, or perhaps even you, would feel the same way after hitting wall after wall after wall. But it's certainly the case that even on planet Earth, where we discuss that life may have had a unique origin, the arising of intelligence and conscious self-awareness, that also seems to have been a miraculously improbable event that allowed that to happen.
Yes.
Right? I mean, what if the meteor hadn't wiped out the dinosaurs? I mean, would we all be sitting here and we'd all be dinosaurs and having this conversation, or would we never have gotten to that place?
I suspect not. I mean, I think that there would be lots of dinosaurs around, but it's.
But we would,
I think it's a major step. We were talking about whether the origin of life was a big step, and perhaps it was. So we don't. And I said that was a corollary of whether we think there's life elsewhere. So there might be swarms all over the universe of bacterial type life. But if we ever discovered life elsewhere, it would have to be by radio waves coming in, and that means it would have to be technologically sophisticated life, and that means it would have to have overcome another barrier, so that the barrier from bacterial level life, maybe there are several intermediate ones, and then up to the kind of life that's capable of producing radio waves that we can detect.
Right, so long if it's far enough away. I mean, if it's near enough by, in principle, we could.
If it's near enough by, yes. But I'm suspecting that's probably not. I suspect that if we ever do discover extraterrestrial life, it will be by SETI, and in that case, we have the question, do we have a second barrier, or maybe a third or a fourth barrier,
right,
and to produce the sort of intelligence? We don't have to get into consciousness. I mean, it could be unconscious, but
if it could talk to us, that would be good enough.
But if it can produce radio signals, then that's a much more mundane question than the question of whether the light, as you say, the consciousness light is turned on.
So do you think if we discovered life that's not intelligent, would it make much of a difference ultimately to life here? I mean, it would be an exciting moment and so on, but would it then, we have what? It used to be that you had a week news cycle, a 24-hour news cycle. Now it's like every 10 minutes. So would this be like from 10:30 to 10:34, bacteria found on Mars, and then by 11 o'clock Trump would do something else and everyone would forget about it?
I like to think that it would change the way we think about our own life, but maybe it wouldn't. I think it really would if we were contacted by intelligent life forms elsewhere, especially as if it was intelligent enough to get its signals here, it would have to be a lot higher level than us, and so we would have a lot more to learn from them than they would learn from us, and so. Right. That really ought to shake our confidence and shake our...
Now, if it was far away, it would be a pretty slow conversation.
You couldn't have a conversation, no, that's right. But you could listen to them.
Right. So let's say we did have this conversation going. Let's say we get over the barrier somehow. We learn how to communicate with each other, and fancifully, let's imagine that the conversation happens more quickly than
500-year interval between.
So let's put all that to the side for just a second, which is certainly a technical detail. Could you imagine that the logic by which this intelligent extraterrestrial society lived and thought and worked and created would be fundamentally different from the logic here?
I love that question. I mean,
you've heard this question before? I mean,
well,
is this frequently asked to you? I feel so hackneyed. I thought it was a good question.
That's why I say I love it. I mean, clearly they would have Pythagoras' theorem. They would have numbers. They'd have geometry. They'd have. But I'm like you. I'm curious to know whether they'd have a completely different kind of question that we don't have.
Because there are, in mathematics, you're probably familiar with, different kinds of logics.
Yes.
And, they're interesting mathematically. People study these logics. There's multivariate logic where it's not just true or false. It can be somewhere in between. There's a subject called quantum logic, which in some sense is modeled on quantum mechanics, where it's not just the particles here or over here, but it's some quantum mechanical mixture of the two. So is it conceivable that one of those or some other kind of logic would yield a kind of engagement with the universe that's utterly distinct from ours?
Well, it's sometimes suggested that the way in which we think, which is not the way quantum theorists think, but the way people think, ordinary people think, is dictated by what's the necessary kind of logic that you need in order to survive on the African plains.
Yes.
And so when you're a medium-sized object hunting other medium-sized objects and moving at medium speeds, then you need a different kind of logic than if somehow you could imagine that we were shrunk to the quantum level, we would have a different kind of logic.
Yeah, right. Now you can well imagine that some very forward-thinking one of our remote ancestors who was out there in the savannah and actually thinking about quantum mechanics got eaten, right? So that's why it takes so much dedicated effort for us to figure out these quantum laws, because it's not built into our evolutionary structure. It didn't have any survival value. Presumably that's a reasonable way of thinking about it.
Yes, I mean that's kind of what I meant, but not quite in those terms. I'm curious to ask an advanced theoretical physicist, which is I don't often get that opportunity, but the weirdness, the sheer utter mind-numbing weirdness of quantum theory. Are you one of those physicists who, as it were, takes that in your stride and says, well, I can't conceptualize it, but the mathematics works, and so and the predictions that it produces are verified by experiment, and so in some sense it's got to be true? Or do you lie awake at night wishing you could understand, or perhaps you do feel you understand it
Well, I don't feel I understand it in the same way that I understand tables and chairs in a classical experiential perspective. And I do wish that I had quantum mechanical reasoning in my bones. I think I would engage with the universe in a radically different and quite wonderful way. I mean, look, we all know if I won't do it, but if I took this and I tossed it to you, you'd put out your hand, you knew catch it, which is an amazing thing, because you didn't do the Newtonian calculation of the trajectory of the bottle. You just sort of felt it in your bones, and you put your hand there and you catch it. So it's so mundane, but it's so wondrous that we're able to do it, and it just shows the power of imbibing the rules that are relevant on the scale at which survival takes place. And I wish I had that same quality when it came to an electron in the hydrogen atom, that I could just sort of feel the s orbital, and I could feel, the p orbital, like be in my bones, right? So if you ask me some question about the hydrogen atom, I wouldn't have to go calculate. I would just sort of be able to do what you did when you put out your arm and catch the bottle. So I don't have that. I wish that I did. At the same time, I certainly do use the mathematics to gain a confidence with the ideas. You ask me a question and it doesn't, send me scurrying for cover, because I'm like, okay, I don't know really fully how to think about that, but I know how to set it up, I know how to solve the equation, I know how to interpret the mathematics, because it's been going on for 80, 90 years, and that gives me at least some semblance that I know what's going on. But it isn't in the same intuitive, deep intuitive way, and that is a strange way to live, right? You live, as a physicist, your career, whatever, 30, 40, 50 years, and most of the time, you kind of don't really know what's going on.
I mean, do your colleagues, do any of your colleagues claim to have it built into their bones, so to speak, or do they all accept pretty much what you've said?
I don't know that I've ever heard anybody really say that. Well, actually, no, there is one. He came over to dinner. My wife is here somewhere. Tracy, remember Andy Strominger came over to our apartment, a Harvard physicist, and he was really angry at me for saying what I just said in public. He saw it in some version of this in some conversation, and he said, "You're giving the wrong impression of quantum mechanics. We fully understand it." And I was like, "Andy, like, what do you really mean by that?" But what he meant by that was, we have the equations, we have the math, we do the calculations.
Which is just what you said anyway.
Yeah.
Yes.
So I don't know that he would say that he has it. I'll have to, I believe that he did not say that he had that deep intuitive understanding.
Yes.
But most people who think deeply about quantum mechanics even say that it's an incomplete subject as currently formulated. We do not know how to go from the fuzzy probabilistic mixtures of the reality that the math is telling us about. The electron is 50% here and 50% there and is in some sort of fuzzy mixture of the two. But yet when we measure the position of the electron, we always find it here, we always find it there. So somehow a transition happens from the fuzzy probabilistic reality to the single definite reality of common experience. And we don't have an equation for that. We just say it happens. Or I should say, people have proposed equations for it, but we have no idea if they're right.
Well, Schrödinger ridiculed the Copenhagen interpretation with his cat, his famous cat thought experiment. I'm aware that there are others who talk about the many worlds interpretation, who will say in terms of Schrödinger's cat, there are worlds in which the cat is alive and there are other worlds in which the cat is dead. That seems to me to be, although a hideously unparsimonious way of looking at things, nevertheless, it's not totally ridiculous the way the Copenhagen interpretation.
Right, yeah. So just quickly, so the Copenhagen interpretation just says, hey, we don't understand the process, but here's an algorithm, here's a procedure. Follow the procedure, or as it's usually described, shut up and calculate, right? That's the summary of the Copenhagen approach. But that's not a theory of physics, right? That's a set of instructions.
But I thought in terms of the cat satire, so to speak, the Copenhagen interpretation would say the cat is neither alive nor dead until you open the box.
So that's what I'm saying. The algorithm is open the box, and at that moment, one of the two happens. How does it happen? I don't know, but it happens. We see it happen. Now, that's a little bit of a cartoon description. There have been more refined versions of this story called decoherence that have been developed over the decades. So it's not like it's stagnant, but it's not really a theory. It's just a set of rules. But let me just quickly add the one point that you did make about the many worlds being unparsimonious. And you really need to bring the right barometer, the right yardstick.
Many worlds would be that there are lots of worlds in which the cat is alive and other worlds in which the cat is dead. And
that's right. So the many worlds basically says if quantum mechanics says that this can happen and this can happen and that can happen with some probabilities, then actually all three do happen. They all happen in their own separate world. So every outcome allowed by quantum physics takes place. Now that sounds incredibly uneconomical, right? The world is just becoming, the landscape of reality is becoming larger and larger with all these distinct realities allowed by the unfolding of quantum mechanics. But here's the point. It is the most parsimonious theory when you look at the mathematics. So the equation is pristine and sharp, and if you stare at that equation long enough, this is where the equation takes your thinking. If you just literally look at the symbols and say, what are those symbols telling me? Whereas all the other approaches add in other equations, other ideas, baggage, and that sort. So if you use the yardstick of the number of universes, out of control. If you use the yardstick of the mathematics, it is as simple as it can possibly be.
Well, I like that. That's very good. By the way, have you seen, there was a lovely New Yorker cartoon of a vet's waiting room, and the people were standing around with their dogs and cats and things. And the nurse is coming out and talking to a gentleman sitting there and saying, "About your cat, Mr. Schrödinger, I have some good news and some bad news."
That's very nice. So I'm glad you asked about quantum mechanics, because it does give a sense of how our intuition can completely mislead us. The things that our intuition tells us are true or false may not even be describable in that language. In the quantum world, it could be a mixture of both. And that is a fundamental layer of reality that our way of thinking about the world is not tuned into, not tapped into. if you're a trained quantum physicist, you can work it out, as we're describing, but intuitively it's just sort of not there. So I guess the question that comes from that, sort of relevant to other things that you famously talk about, what does that tell you about the nature of truth? I mean, you spend a lot of time, important time, going out into the world as an advocate for truth, and we all know what that means in sort of everyday scales, but if we can be a little bit more expansive in our thinking here, does this disjuncture between the truth at the level of fundamental physics and the truth at the level of intuition, excuse me for that spittle that just went halfway across the stage, does that distinction give you any pause?
Well, we came into this by talking about if Martians had a different kind of...
Yeah.
I mean, to what extent is our conception of logic and truth governed by by what's necessary in order to survive on this planet? And if for some reason you need a different kind of logic to survive on Mars or Alpha Centauri or somewhere, would we have a different conception of truth? It's a dangerous time to be talking about this with fake truth and post-truth. And
yeah.
I think of myself as a naive realist. I mean, I think there is such a thing as truth. But quantum weirdness does worry me. But I'd like to think that although our view of the world is no doubt shaped by the need to survive in, as I said, in Africa, hunting buffaloes and things, I think I want to say there is such a thing as objective truth. I mean, I hate the idea which we hear from some academic circles that, I don't know, truth is a social construct and, that there's no...
Well, I obviously I would agree that when it comes to the fact of the matter about the electron's magnetic dipole moment, right? That's a number that quantum mechanics predicts. We go out and measure it. They agree digit by digit by digit, 9, 10 digits down the road. And that does feel like it qualifies as truth in some way, or close, extremely close approximation of truth. But when we go to sort of higher levels, I guess I feel worried about scientists going out into the world. And you're right, it's a very curious time because, you know, we're meant to be out there proclaiming the facts about the world and the facts about the matter and the truth of the world. But with my experience in realms that are so different from the truth that we normally talk about in everyday life, it gives me some pause. Mm-hmm. Can you make me feel better about that a little bit?
No, because I live in a more naive. I mean, I live in a simpler world, and objective truth is something that we all live within our everyday lives, and that's the world in which we evolved, and so I don't have that difficulty. I'm just kind of aware. I mean, I have difficulty not just in the quantum field. I mean, there are other parts of physics which upset me as well. Well, in cosmology...
I'm happy to help if I can.
Cosmology, for example.
Yes.
I read that the Big Bang, that at the moment of the Big Bang, everything was compressed not just into a small volume, but into an infinitely small volume. I mean, that worries me.
Yeah.
I mean, I'm aware that a solid object like a table or a rock is mostly empty space, but nevertheless, if you were to compress it and get rid of all the space between nuclei, it would not just be the size of a proton. I mean, it would still be a fairly substantial chunk of stuff.
In fact, you can calculate. I once did a small calculation that if you were to take every person that's ever lived on planet Earth and remove the space between the electron and the nucleus and all of their atoms, then the remaining particles without that space would fit inside of a baseball.
But a baseball is a pretty big thing.
Pretty big thing. No, that's my point. I'm agreeing with you.
I mean, that is an astonishing calculation, by the way. I mean, it really is. Is that really right?
It's really right. Yeah. And I have the baseball right here to prove it. No, yeah. But
Okay.
But actually, I'm agreeing with you.
Yes.
You know,
Yes.
and so we have exactly the same worry that our equations, Einstein's general theory of relativity, are the equations that we use here. Those equations actually break down at time zero. Time zero is when everything would be crushed to
Yes.
this infinitesimally small size, and the equations themselves break down, which means that we don't really know what's happening at time zero, which is why, for instance, we've developed ideas that have tried to go beyond Einstein's equations, really to answer that very question. That question can be viewed as the motivation for a theory like string theory or other attempts to put quantum mechanics and gravity together to try to resolve that puzzle. We've not yet resolved it yet, but I will say one thing that is often misunderstood. So today, we don't know whether the universe is finite or infinite. Right. In fact, Einstein once famously said there are only two things that might be infinite: space and human stupidity.
Yes.
And he said he wasn't sure about space. You know, and we're still not sure about space. But if space does go on infinitely far, then as you go further and further back, yes, it shrinks. But you know, if you take infinity and you divide it by 2, what do you get? Infinity. Take infinity divided by 10, what do you get? Infinity. So things in the universe get closer and closer together, but the grand expanse of reality at time zero at the Big Bang would not be infinitesimal. It would be infinitely big, but it would have infinite density. So the idea of a little tiny dot from which the entire, not the observable universe, but the entire universe emerges, that could well be the wrong picture.
Well, but I don't know why you make it so difficult for yourself, because you, well, in the following sense, Hubble's law, and you reverse the process in it.
Yes.
I mean,
yes.
I can see, you know, you crunch it down to something a bit bigger than a baseball.
Yeah.
Why go to something infinitely small?
Good. You could imagine running the film in reverse, the cosmic film in reverse, and you simply stop it a couple frames before time zero. You say, let's just stop it right here, and we'll go forward in our explanations from that starting point. We're really goddamn ambitious as physicists, right? We want to go. We really want to go to time zero. We really, and so it will feel to us as though we have left out the essential quality of cosmology. If we have to sort of by hand say, oh, stop the film, we don't know what's going on, and go further from there.
But why, when you get to time zero, does it have to be infinitely small? Why shouldn't it be the size of a cannonball? Or, I mean,
if our mathematics told us that, then indeed.
So the mathematics tells you...
So maybe I didn't say it clearly before, but in Einstein's general theory of relativity, when you metaphorically wind the cosmic film further and further back, imagine the universe is finite in size, so we don't have to worry about the infinity, then indeed it goes right down to zero size. The radius of the universe goes right down to zero. And if somehow you could correct Einstein's equations, which we hope maybe string theory will do, so that with the correction, when you wind the film back to zero, the universe does not have zero size, but it's a little tiny nugget, like a baseball or some smaller entity, then that would be a very satisfying cosmology to start from that, from that point
but the mathematics
forward.
doesn't let you.